you've gone over kind of an introduction to proportions, we're going to dive headfirst into understanding proportions. So I want you to take a look at this problem, take a second, and then come back to talk about the answer with me. So the problem says Giant is running a sale on Granny Smith apples. Complete the table to show how much the apples will cost at different pounds bought. So we see here that they're running a special. It's $1.69 per pound. So what I want you to do on your own sheet of paper or in the printed notes or on your iPad typing in, okay, I want you to figure out how much 2 pounds would cost, 3 pounds would cost, and 3.5 pounds would cost. I'll be back on in a second to talk about our answers. All right, so here we are now with our answers. 1 pound of Granny Smith apples costs $1.69. 2 pounds costs $3.38. 3 pounds costs $5.07. And 3.5 pounds costs $5.92. Now you could have figured this out a couple different ways. You could have just added $1.69 to these two and then added half of $1.69 here. Or you could have multiplied. You could have done $1.69 times 2. $1.69 times 3, and so on and so forth. Whether or not you realized it, you were solving a direct proportion question. So that's really what we're trying to understand in this unit. The relationships between numbers that are not the same, but relationships that regardless of how much of something you have, that relationship is true. Okay, so on your own sheet of paper, you should be writing down our SWABOT for today, which is identify direct proportions from a table. We have 2 key vocabulary words that we need to write down. We need to write down ratio and proportion. As you're writing these down, if you need to pause the video so that you have a chance to copy them down, feel free. Okay, a ratio is a comparison of 2 quantities. And so ratios can be written in 3 different ways. We, most of the time in Math 7, we write it as a fraction. So if we wanted to compare, I don't know, girls to boys in a class, we might say that there are 3 girls to 5 boys. Or we could write it 3:5. Or we could even write it in words. 3 girls to 5 boys. So a ratio is a comparison of any 2 quantities. A lot of times fractions, ratios can represent fractions, but not all fractions are ratios. Okay? Now, a proportion has something really, really special or a kind of relationship with ratios. And a proportion is an equation where 2 ratios are equal. So a proportion isn't just one ratio, it's 2 ratios. And they're 2 ratios that regardless of their values are equal to each other. So let's take this example of 3 girls to 5 boys. Maybe that's Mrs. Gwines' room. Okay, so my room has 3 girls and 5 boys. And then we find out that the entire 7th grade has 36 girls to 60 boys. This is a proportion because if I reduced them, they would be the same. Or if I multiplied by 12, 3 times 12 is 36 and 5 times 12 is 60, they're the same thing. They represent the same ratio, just in different kind of areas, right? So this is Mrs. Gwines' room, and then this is the whole 7th grade. Pause the video if you need to copy down the notes, and then we're going to get started talking about the math. So here we have a question again about a supermarket. It says each pound of strawberries costs $2. So 2 pounds of strawberries cost $4. 3 pounds of strawberries cost $6, and so on. The table shows the cost Y dollars for X pound of strawberries. So take a second and think to yourself, what happens when we compare the price of strawberries, which is here, to the number of pounds? Okay, the price of strawberries does what? As the weight of strawberries does what? If you're thinking to yourself that the price is increasing as the weight increases, you're exactly right. And you're on the right track to think about direct proportions. We see that as I have more pounds of strawberries, I'm going to have to pay more at the checkout. So here's something really, really, really important you should be writing down in your notes. You should be writing constant of proportionality. And you should be writing these two formulas exactly as you see here. Okay. The constant of proportionality is this guy. And that's telling me that when I set up a ratio where the value of y is compared to the value of x, I get k. And then the equation of a direct proportion tells me when I multiply the constant of proportionality times the x value, I get the y value. If something is directly proportional, then the constant of proportionality is the same regardless of the value of x or y. This can seem a little funny because we're talking about letters and x's and y's and k's. So let's take a look at some real examples. A pet store owner uses a table to decide how many of a certain type of fish to put in an aquarium. Tell whether the number of fish, F, is directly proportional to the volume of water, G, gallons. If so, give the constant of proportionality and tell what it represents in this situation. Then write a direct proportion equation. Okay? So the first thing that we've got to do, we've got to figure out if this represents a direct proportion. So I'm going to remind myself that to be a direct proportion, I need to have a k value that's y divided by x that's the same across the entire table. It's saying if the number of fish F is directly proportional to the volume of water G. So that's like saying F is to G. So F is my y value and G is my x value. So now I write my proportion or my ratios. 6 is to 4, 15 is to 10, and 30 is to 20. I still don't know if these are all equal to each other because they're not simplified. So I have to make sure that I simplify them. We are now beyond working with fractions without our calculator. So you are more than welcome to type 6 over 4 into your calculator to find the simplified solution. But 6/4 is the same as 3 over 2. 15 over 10 simplifies to 3 over 2. And 30 over 20 simplifies to 3 over 2. So now, if this is a direct proportion, then each of these numbers are equal to each other. And they are. So the first answer to this the situation is yes. It's directly proportional. Okay. The second question says, if so, give the constant of proportionality and tell what it means in this situation. Well, we figure out the constant of proportionality, right? We figure out K when we figure out whether or not this is a direct proportion. So we know that K is equal to 3/2. But just like word problems with fractions, decimals, or integers, this 3/2 represents something in the real world. So this 3/2 tells me that for every 3 fish, I need 2 gallons of water. And the last part of the question then says, then write a direct proportion equation. So I'm remembering that the direct proportion equation is always y equals k times x. So if that's the case, then my direct proportion equation is going to be y is equal to 3/2 times x. And because I have unique variables here, this is actually going to be f is equal to 3/2 times g. Take a second and copy this down if you need to. We'll move on to another example. Okay. The table shows the distance traveled by a snail, d centimeters, after t hours. Tell whether d is directly proportional to t. If so, give the constant of proportionality and tell what it represents in this situation. Then write a direct proportion equation. Okay, so the first thing I have to figure out or determine is tell whether d is directly proportional to t. So I'm trying to figure out, is d directly proportional to t? So I write my ratios. I have 9/1, 18/2, and 21/3. And I reduce these fractions to their simplest form, an improper fraction form. I don't want mixed numbers. So 9/1 is just 9. 18/2 is 9. And 21/3 is 7. 9 is equal to 9, but 9 is not equal to 7. So this is not a direct proportion. If we find that something is not a direct proportion, we don't have to go any farther. There's no constant of proportionality. There's no number that it's multiplied by every time. And that means then there's no equation either. So if we find that it's not a direct proportion, all we have to say is not a direct proportion and move on. Okay, I want to talk about this example, and then the video is going to pause and give you a second to figure it out. So here we have the table shows the distance traveled by a school bus, y miles, after x hours. So we have to figure out a couple things. We have to figure out if the distance traveled by the school bus is directly proportional to the number of hours it has traveled. So your yes or no question, is it directly proportional? If it is directly proportional, what's the constant of proportionality? And if it is directly proportional, what's the equation? Remember, the constant of proportionality we figure out by simplifying the ratios of y to x. And then we insert that k value into the following equation to show its direct proportion equation. Okay, I'll be back on in a second to talk about our answer. So here's our solution to number 1 about the distance this bus travels and its time. So when I try to figure out my constant proportionality, I set up my ratios where y is over x. So it's 100 over 2, 150 over 3, and 200 over 4. When those are simplified, those become 50 over 1, or just 50. And they are all equal to each other. So the answer to the first question is yes, it's directly proportional. Because it's directly proportional, we know that the k value, which is right here, the one that's the same across the board, is 50. And that tells me for every 50 miles the bus has been on the road, it's been on the road for 1 hour. And because I figured out that k, the constant, is 50, my equation is y equals 50 times x. All right, I want you to try another example. And here we have a baseball example right now as the World Series is going on. The table shows the number of pitches made, y, in x innings of a baseball game. For each pair of values, x and y, okay, we need to figure out if, is this directly proportional? If yes, what is k? And what does it mean? And then write the equation. Okay, take a second. Figure out the answers to each of these questions. Is it directly proportional? If it is, what's your k value or your constant of proportionality, and what does it mean in this problem? And then write your equation. I'll be back on in a minute to talk about our answers. In this example, we have our baseball number of innings compared to the number of pitches. And we wanted to know if the number of pitches is proportional and directly proportional to the number of innings. When I try to determine this, I set up my ratios here, and I compare y to x. So I have 15 over 1. So there were 15 pitches in the first inning. Then there were 30 pitches after the second inning, and 50 pitches after the third inning. To determine whether or not this is a direct proportion, I need to simplify each of these ratios. So we have 15 over 1. 30 over 2 does simplify to 15 over 1. But 50 over 3 does not. It stays 50 over 3. That's in its simplest form. So here, this is not equal to each other, which means this relationship is not directly proportional. And because it's not directly proportional, we cannot answer 2 and 3. We just leave it here. The relationship is not directly proportional. Okay, you are now going to go into Schoology and answer the 5-question exit ticket or activity. Each of the questions looks almost exactly like the examples that we've talked about in the notes. So if you need to, go back and watch again or just see how we get our answers before you click submit so that you get a great grade here at the end of the marking period. As always, if you have questions, feel free to reach out via email or Schoology Messenger, and I'll see you all on Monday.